Hello. Yes, so my name is Carsten Rossenhövel, co-founder of EANTC, one of the I14Y consortium partners, and I'm moderating the panel today. I have the pleasure here to have Alisha Huang from the ITRI in Taiwan. I have Ajesh PK from the I14Y lab, ORAN verification engineer. Alisha is also an engineer, so we're really talking from the realities of the testing in the lab. And Wong, who's director of RF and wireless in VIAVI Solutions. So why are we talking about testing? Most of people think if you go to MWC and even here, like, okay, ORAN works. And of course, yes, it does work. But now we have the challenge. We are off the peak from the Gartner hype cycle, and now we're still not fully there yet at the level of productivity, as Gartner likes to call it. So we need to get things working in the lab. And that's more of a challenge in the daily work. Probably you don't want to hear all of this, so we don't want to bore you with too much details of the hard work that each of the people here are doing. But on the other hand, I think there are a lot of lessons learned. We've had a couple of experiences recently of lab collaboration. That's the topic of today's panel here. And all of us are collaborating in the labs between US, Europe, and Asia. And I would like to explain a little bit to you with the help of the panelists, like what is this about, what are our experiences, what are the challenges, what are the next steps, and so on. So let's get started, maybe just with an introduction of the background of the collaboration. So Alisha, if I can ask you first, like, what are your collaboration activities, particularly on the RIG, XAP, and RAP testing, on the network optimization testing at ITRI?
So, hello everyone, and I'm Alisha from ITRI. And in this year, together with the I14Y lab, focus on the RIG testing on the energy saving scenario. So our goal is to evaluate how well the RIG application can save energy in a large topology. So first of all, we need to build up the test plan, and for the tip using 9 scenario, and we get app supplies from the EANTC, Dutch Telecom, and Fraunhofer, and Zhonghua Telecom is the Taiwan's operator. And we also complete this test plan and deliver it to TIP for contribution. And we also build out the simulation environments using VIAVI AI ISG to build up the large topologies with 52 cells and 800 UEs in this environment. So thanks.
Right, and Ajesh, from the I14Y lab perspective, how are the collaborations going, particularly in the end-to-end testing these days?
Yeah, definitely. So hi, myself Ajesh. So collaboration for I14Y lab means, we are an open lab here working with multiple vendors, multiple STOs, and also test organizations. So here we day by day deal with all these vendors, asking, testing things, and doing some joint activities. So this time for us, the collaboration, so as mentioned, so we have some collaborations already with ITRI lab as well as VALOR lab here. So for collaboration is for us is how to accelerate. So our own motto. So we work on a motto of accelerating time to the market. So how fast the products come to the market after testing. So whatever that really boosts this goal of making all these operators or the vendors products that can be deployed faster in the market. So in this point, the collaboration really makes sense to involve with other labs to do some joint collaborations in like testing or validation, so that all these results would deliver us a consistent manner, and as well as this really supports this ecosystem to be evolved. Yeah.
Right, thank you. And Ian, we've been working together between I14Y lab and VALOR. Maybe you can introduce that a little bit.
Sure. How many of you have heard of VALOR? Okay, I would say 50%, so I don't think our marketing has been so successful so far, but yeah, so it's okay. So VALOR stands for VIAVI Automated Lab as a Service for Open RAN, VALOR. So that acronym, actually I came up with that. Anyway, it is a lab in the United States. It's actually primarily based in Chandler, Arizona. Our VALOR lab director is here, Eric, back there. So if you want to talk more about VALOR, come to our booth. You can meet him. And it is funded by the NTIA, thanks to our NTIA colleagues that are here. So we are one of the 3 labs that won the NOFO awards in the US. And one of our goals is to really improve the ecosystem of labs around the world and improve our test plans in the ORAN Alliance, in TIP, and elsewhere. And that's basically what we embarked on, I would say about a year ago. It actually just stemmed from a lunch conversation with Andreas primarily, and say, you know what, we have all these tests. We need to make sure that these tests are reproducible and repeatable across the different labs. And we found out some interesting things, which we will discuss probably throughout this panel. But and at the end of this panel, you need to know what's the difference between repeatable and reproducible. There will be a quiz, okay? But we'll cover that later.
Exactly. But first, thanks for reminding about the importance of lunch conversations. We'll try to finish on time. So that's actually a good point. That's a mouthful of the term consistent and repeatable testing. And we found quickly that we need to understand that very carefully, and also that one of the terms isn't exactly correct. So can I hand back to you immediately?
Sure, yeah, I used to teach a class, so we're gonna do it this way, right? Like, there's really 2 terms, at least officially, right? It's repeatable and reproducible. Who thinks repeatable is harder than reproducible? We've got a couple, 3. Who thinks reproducible is harder than repeatable? Got more? Well, in this case, the majority did win. So, reproducibility, right? And maybe let's start with repeatability. Repeatability means you do a test, and you keep on doing the test, and you get consistent results. So consistency is a characteristic of a repeatable test. But reproducibility is that you actually see that it's consistent across different test lines and across different labs. And obviously, that's actually a lot harder to achieve, because every lab has their own infrastructure, they have their own test systems, they have their own processes, and it's much harder to get to reproducible. But reproducible is something the industry needs if an operator were to trust an open lab to do a lot of their baseline testing, which was kind of part of the vision of this concept of open test integration centers, or OTICs, right? So I happen to also be the co-chair of the TIFG, Test Integration Focus Group in ORAN Alliance. And that's one of the tenets, is to actually have this network of labs that can offload some of the baseline testing from operators, again, to make the business case for ORAN definitely a lot better. So repeatable versus reproducible, don't forget.
Right, and Ajesh, so what do you think, how important is it, why is it important at all to have reproducible and consistent testing, particularly for the work we're doing at the I14Y lab?
Okay, so I would wear the hat of an engineer here. So, because basically we do these testing activities all time in the lab, yeah? So whenever we collaborate with the other labs to bring up this repeatable testing reproducibility. So first thing we look for is, hey, how can we achieve this, yeah? So first thing we look for is, okay, basically what kind of specifications we would rely on. So basically we are now relying on 3GPP as well as the ORAN specifications. Then the next thing comes is, how can we make sure that test equipments or the reference framework is a golden framework, where that most of the involved entity or the elements are literally the same. Yeah, for example, if vendor A provides us something to be tested and it has to be repeated across the labs, what the vendor provides should be the same with respect to the software versions, with respect to how it behaves. Yeah, only then, if the equipment, if the unit behaves in the same way across all the labs, then only we can call it as repeatable or reproducible, right? So that's where. So we, as an engineer, we totally work that in a way that all the other elements which we require for the testing this particular element is literally the same or can be trusted. Yes, because if you test something and I test something and I totally get a different results, then it's not consistent or reproducible. So we have to make sure that all our test environments, everything is tuned and all the campaigns are proper, and also we make sure all the readings we take, all the measurements we do is really proper ones, and as well as can be trusted. Yeah. Otherwise, if many labs have many results, then nobody trusts us. So especially operators, for whom we are doing. We are doing it for the operators. So the operator should find the value. Okay, these guys have done so much things and it looks good and it is repeatable across the lab. Yes, why not test it? Yeah, why not trust this? So this is where we really focus on. So from the base, where we take the specifications, from how we read the values. Everything we make sure that everything is repeatable as well as is consistent, as well as it's all reproducible as well. So I'm just saying from engineering point of view how we test this.
Sure, thank you, that's appreciated. And I think my experience is over the years since I've started doing testing, this kind of reproducibility comes only when the technology is mature. So after 10 years, it's pretty straightforward, right? Everybody understands everything clearly. Yeah. But now we have areas in ORAN, like rig testing, for example, which are very much research oriented, and you're very involved in that, Alisha. So maybe you can explain how you see the consistent repeatable testing, particularly for energy efficiency and rig testing.
Oh, thank you. So I think the consistent and repeatable testing is crucial for energy saving because this rig application is sensitive to the environment. For example, when the rig application executes the results in the two cells such as small topology, but in the large topology such as up to 52 cells topology, the results will completely different. And this difference or variation will raise the question is that if we observe these results, it reflects the actual performance of this rig application or just the influence about the test setup. So before we executing the testing, we need to align across different labs to align on the standardized and the test setup topology. So thank you.
Yes, thank you very much. So now let's get to some more practical description, like what has been done. So we have run a pretty major project, or not project, evaluation of consistent repeatable testing between I14Y and VALOR Lab recently. And maybe Ajesh, I can ask you, what were the practical ways to getting to that level of reproducibility? So what needs to be done?
Okay, so as mentioned before, so the first thing is, so as Ian mentioned, it was starting of our lunch conversations, right? So the first thing is to evaluate what we have, yeah, here, with the evaluate what the capabilities of the lab is, and what are the test equipments we use, what are the standards we see, how are the campaigns we have created, yes. So then, yes, so, and finding this system under test. So mostly we did this activity using the end-to-end, where we had the radio from vendor A and the CUDU from vendor B. Yeah, so basically now the SUT is the same, and now we have to get aligned with the other equipments, because in an end-to-end there are multiple other elements involved in an end-to-end, like the core, the traffic generator, the UE emulators, and many things. So we want to align these, their configurations, and also as mentioned, so when it comes to the testing, mostly the engineers refer the ORAN specification, right? So there could be a understanding differences in the understanding, because all these differences or interpretation of the specs really affect the testing. For example, if an engineer A interprets in a different way and he creates a campaign in a different way, and engineer B understands, oh, this is something what it's not really working. So he will define the campaign in a different way, right? At the end, you get two different results. So this has to be avoided. So we have to have a proper alignment with the labs, how to understand really the specs and what is to be achieved, how to do it. And based on these alignments, we will make sure that all the other equipments are tuned, calibrated, and the readings we take is proper. And in that way, we make sure that the units that is under test does not produce a different result, because basically it's the same unit that's been sent to the EANTC lab or the I14Y lab, right? If I get an RU and he gets 1 Gbps throughput and I get 500 Mbps on the same throughput, then it doesn't make sense, yeah? And the operator definitely won't trust this, yeah? So all these are things starting from the specification to the alignment of the test equipments and how to do the test, how long it should be done, and how the reporting should be made proper. So all these alignments are done at an engineering level, and it's reviewed by all the managers and all the involved parties, and we make sure then we start this testing. Yeah, of course, then at the end, some point of testing, you will find some difficulties, but there we will make sure the root cause analysis is done, and also what exactly has gone wrong. So this is how we make sure that.
Yeah. I think it's a very accurate description, and it has taken a while. So, Ian, how did things look from your side about getting to consistent and repeatable testing in the actual lab day-to-day work from the VALOR perspective?
Yeah, I mean, I would say that there, through our exercise, there were definitely some surprises. And I mean, a surprise is always good because that means you actually learned something, right? So even in the case of exactly the same system under test, the same test equipment, which also comes from our company, right? It's still, some aspects were still challenging. And I think a lot of it stems also from the fact that the test plans themselves, in some cases, were not as crystal clear. And so at the end of the day, that's kind of one of the biggest learnings. And I'll cite one example is on the core, right? We would say, oh, the core, I mean, at first we started with different cores, right? You have a different core, we have a different core. And that's not a big deal. We're just doing functional tests. We just get some KPIs. But guess what? The core ended up affecting the result. And because, again, we were measuring latency, and so obviously the latency of a registration of a UE, right, was highly affected by the core. But then to really have a test be reproducible, we can't enforce every lab in the world to use the same core or core emulator, right? So we needed to get to the point wherein what do we need to do on the test plan standpoint to make sure that this doesn't happen. And so through EANTC and VALOR collaboration, we actually submitted some change requests to the specifications to make it much clearer that, hey, in your test equipment environment, you need to make sure that these aspects, don't affect your test. And here's some examples, and here's some recommendations. So, and that's just one test, right? Out of a test spec that's now 235 pages. So we need help. But at the end of the day, I think that's kind of the exercise we're undergoing, so that at least at the end of the day, we can get to that reproducible test, which is important for again, gaining trust. Yeah.
Right. Thank you. Yeah, and together with ITRI, we are still at the starting stage, I would say. We haven't really run any similar tests between the labs yet. We have just, worked a lot on test plans. And I think we've reached a good plateau there, thanks to your support and engagement. So what is your take on getting to the same level of testing comparability on the RIC and XApp RAP scene, Alisha?
So yes, for the rig testing, we need to standardize everything. So the first one, we need to align on our test scenario. So we need to set up the same scenario, the number of the cells, the number of UVs, the UVs traffic patterns, and the UV movements path. And all of this, everything is need to standardize to the parameter that each other lab can use in the VIAVI scenario. So it is tend to ensure that the scenario runs and the rig application receive the same data formats and have the same results that can ensure the results can directly comparable across different labs.
Right, thank you. Yeah, and I'm sure we will see quite a number of challenges there in the test execution as well, because the number of parameters and variations in rig testing are even, at least comparable to the end-to-end testing, maybe even more complex. But the idea is to also provide some feedback to the SDO, to the test specification, and then to help the industry to make things more reproducible by describing it also for everybody. So we've already started talking about the challenges. So do you want to add something on the challenges, Ajesh, that we've seen in the VALOR I14Y lab, and what we can learn from them?
Okay, definitely. I think Ian already mentioned some challenges. Yeah. So whatever I said in the before question was, it's all the ideal case, but it never happens every time. So many challenges. So we did, for this end-to-end testing, we did scrutinize this, some of our test specifications, and we selected a similar set of test cases, and which we are wanted to execute in this. So then after we start executing these test cases, and because we are not really comparing the results at the time of the executing, yeah. So we worked in a way that, okay, VALOR does it independently, we do these testing independently, and after 1 or 2 months, we join into a call and we see how it's been done, yeah. Then we find, okay, you got for some test cases, you got much higher throughput, and we didn't get higher throughput, yeah. Then we sit and, okay, scrutinize it, it or find a root cause analysis, like why this exactly varies. Some had a more variation than 50%, right? And we really went into this, what went wrong. So most of the time we end up maybe that it's an RF attenuation issues or the configurations. For example, for one of the TCP test cases, I remember, right? You are getting much higher throughput, we are not getting so throughput, so then we scrutinize it. Okay, what went really wrong? So at the end, it could be the configurations of the windows or the configurations of the bandwidths, because we decided to run independently. Otherwise, it would be just copying of the campaigns, what you have already done and what we are doing. So it doesn't make sense. So we wanted to also analyze how the engineers interpret the specs. Yeah, and we want to compare it. We want to know where exactly the gap is, because we wanted to contribute all this to back to the society or the ecosystem for the standardization organizations to fix it. Yeah, because somebody has to test it. Otherwise, the specs will be there, and if nobody is really doing some real testing, and there is no opportunity to fill the gaps or clear the specs if something is there. Yeah, so this is how we did this activity.
Right. Yeah. Speaking about test specs, thank you, Ajesh, for bringing this up. So, Ian, you're a co-chair of the ORAN Alliance Testing and Integration Focus Group, the TIFG. So, what do you think is the role of the ORAN Alliance here? What can be done to support this topic from the standardization point of view?
Yeah, no, I think a organization like the ORAN Alliance is critical, right? Because that's where the specs are open and everybody can see it, and then people can scrutinize it and execute it in their own labs, right? And so absolutely standardizing this is the most scalable way of truly enabling the whole ecosystem, right? And I have a fellow co-chair of TIFG there as well, PJ. Say hi, PJ. All right, so from DT. And our job is to make sure our specifications are solid. And in a way, it's kind of a, I'm in the position now of criticizing ourselves, right? And it's important, right? You need to have self-reflection and understand, okay, this industry over what, 3 decades, all this testing has been done and concentrated now in just a handful of really big companies, right? And we're in this start of this sea change of why don't we open that up? Why don't we allow more open labs to participate, more smaller vendors to participate? And it's a journey, right? We can't expect an overnight success. And I think, but we need an organization like ORAN Alliance is, I think, the best place, to be honest, because again, you have the operators there, the vendors there, the test labs there, the OTICs there, and basically everybody in this ecosystem represented. So we want to see you participate and help us get there. And this exercise we did with 2 labs, right? We want to scale that out to more labs, right? And we scaled that out to more test equipment vendors, even to our friends in Keysight, right? We want them to be involved, right? It's not just about VIAVI or VALOR or I14Y, right? I mean, in order for this to be a successful ecosystem, reproducibility needs to be achieved across any lab around the world. So.
Yeah, definitely. But before we go to the community outreach, just one more question regarding standardization, because with ITRI, we're basically working with the Telecom Infra project. I see also Abdel here from TIP, so hi. And so typically from the ORAN Alliance, I know that we're doing standardization for product testing, for module testing, end-to-end integration. But now with the RIC and optimization, we're talking about the use case applications. And so we're also you providing feedback to TIP and contributing that test plan, right?
And yes, so within the TIP, the RIC testing is belonging to the TIP Open RAN VIA subgroup. And in this subgroup, they already defined 16 different scenarios about the RIC testing. So when the energy saving is belonging to the number of 9, and in this scenario, they focus on how well the RIC application save energy without harming the user experience. So when we conduct our test plan, we need to focus on the pass-fail criteria, not only the energy saving percentage, but also the user experience parameter, such as like the degradation of the throughput. So to ensure that the user experience that suffer the loss at all.
Right, thank you. And what do you think are the remaining gaps and the next steps for you?
We already have modeling such urban urban areas and traffic patterns across different labs. But to be honest, we need to build up the lab topology and get the information from the real world. But the real world network is very complex because the traffic will go up and down constantly across time and location, and it will be directly affect the rig application to the mechanism to tell about how to switch on or off. And so in our test plan, we still have missing something like the multi-band interference or such as like multiple slice configuration. So we think that we also need to get more material or define more complex parameters from the equipment, such as like VIAVI and some actual information like the actual device to build out a more realistic environment to testing the application.
Right, thank you. And I think there's going to be a lot of work coming, particularly for the use case definitions, because that's something the industry hasn't done so much yet on a standardization level. And I'm also happy to contribute there and to the TIP program, so just as a side note. So Ajesh, from the I14Y perspective, what are the next steps and programs you are working on to improve the consistency and reproducibility?
Okay, so from I14Y point of view, so we really want to become like a reference hub for reproducible results and repeatable testing. Not only just an end-to-end, we want to work with all the labs collaborating across the globe, doing this repeatable testing, and not just in the area of end-to-end. We wanted to explore what's happening in the rig, what's happening in the other entities or other elements, and also we wanted to little more extend or expand this testing activities where we could put some more automation, strengthening our CI/CD platforms. And for example, it's just not between the labs as well, because it's inside I14Y. We have a bunch of engineers who are sitting behind the stage who made these all kind of things happen. So we want to expand this to other different areas of Open RAN, and also we wanted to have more labs added to this activity, or even I would say like some activities like passing the test or like kind of a round robin method where we pass on one device to be tested to the other labs, and let's see how the things are repeatable. Yeah. So we wanted to really collaborate with more labs, expanding our all test areas.
Yeah. Exactly. I couldn't agree more. Thank you. And I would like to add, I mean, the platform testing is something that you and I don't do, but there are other consortium partners in the I14Y lab who are also active on platform testing. It's not only the infrastructure and the applications, but also the cloud edge platforms and other platforms underneath. So, and of course, automation will help a lot, yes, because we're only a little more than a handful of engineers and we cannot do everything manually. So, Ian, for some closing words, like what do you think are the next steps from your point of view?
Yeah, I'd like to plead, call to action really for the ecosystem, right? Like, imagine in 2 to 3 years, a network of trusted labs, right, around the world that operators are actually engaging with. That we get to a point where in an open testing lab where tests are conducted in a baseline manner, not operator specific, but it's enough that several operators will say, okay, that's a good blueprint, I trust those results, and now I'm going to offload some of my own testing to that, right? And that's hopefully our shared vision, our common vision. And we invite you to work with us, right? I mean, this is just a nugget of a collaboration. We can have myriad of pairs of labs really trying to make our tests more robust. Right? There are now 20-something OTICs around the world in the ORAN Alliance, right? And there's a handful that are non-OTICs that are also doing a lot of these tests. So it's a plea to work together. We need the labs, we need the operators to provide us the feedback, and we need the vendors to come in and be willing to be a guinea pig. So if you're a mature vendor and you're almost certain that your test will pass, please volunteer your DUT, because then you will be the reference. You will be saying, look, we tested XYZ and it's reproducible across these labs, and you will be put in a very good light in front of operators. So that's our plea. Please work with us.
Yeah, thank you very much. I think I can't add any more. So we're working together with Oran Alliance at I14Y Lab, and of course also with TIP in different programs that are not competing with each other. And yeah, that was just a very quick intro from the machine room, what it takes to do consistent, repeatable testing, to grow the trust. So we're reaching out, we're building the trust with a lot of hard work from our side. We're not waiting for the operators to provide the trust up front to us, you know, or to whatever. So thanks very much for your attention, and I'll hand back to the moderation. Thank you very much.
Thank you all.